Welcome friends. So today we are going to solve a nice PYQ from West Bengal Joint Entrance Examination 2019. But first I would like to request you, please try this problem yourself. Then if you are stuck with the problem, then only see the solution. Because first, if you directly watch the solution, then your problem solving ability will decrease gradually. So let's start the solution without wasting any time. So here the problem is in equal to 0 to 1 x to the power n tan inverse x dx. If an into in plus 2 plus bn into in equal to cn for all n greater equal to 1, that is n is natural number, then we have to check these options. Maybe one option may be correct, or it may happen that more than one option will be correct. So we'll check the solution of this problem first. Next page. Here in equal to 0 to 1 x to the power n tan inverse x dx. Tan inverse x dx. Okay. So here we know this formula. Here we will integrate it by using integration by parts. So here inverse and here it is algebra. So we will take tan inverse x as the first function and this one as the second function, equal to tan inverse x integration dx x to the power n means x to the power n plus 1 by n plus 1 0 to 1 minus integration ddx of the first function. So ddx of tan inverse x means 1 by 1 plus x square x to the power n plus 1 by n plus 1 dx 0 to 1. Hope you have understood this. Now if we put the limits, tan inverse 1 means pi by 4, here 1 by n plus 1, and we know that tan inverse 0 equal to 0. Here 1 by n plus 1, 0 to 1, here we take x square common, so x to the power n plus 1 minus 2. Why we do such arrangements, you can understand after when I do the next step. Okay, so now next page. In, therefore in equal to pi by 4 into n plus 1 previous page minus 1 by n plus 1 0 to 1. Here in the denominator 1 plus x square is present. Okay, so in the numerator part we will bring 1 plus x square to make the calculation easy. So 1 minus 1 by n plus 1, 0 to 1, 1 plus x square minus 1 into x to the power n minus 1 by 1 plus x square dx. Now I think you can clearly understand that why I have taken this x square as common. Okay, from x to the power n plus 1. So now next page. Therefore, in equal to 5 by 4 into n plus 1 minus 1 by n plus 1, 0 to 1. So 1 plus x square by 1 plus x square, so means 1 minus 1 by 1 plus x square into x to the power n minus 1 dx. So here next page, in, therefore in equal to pi by 4 into n plus 1 previous page minus 1 by n plus 1 so here 0 to 1 x to the power n minus 1 dx, integration 0 to 1 x to the power n minus 1 dx, minus here minus plus 1 by n plus 1 okay, I erase this. Okay, so minus plus 1 by n plus 1 integration 0 to 1 x to the power n minus 1 by 1 plus x squared dx. Because here I have done the calculations, so it is more time consuming. So if you feel bored, you can increase the speed in the YouTube player so that you can easily understand all the steps in minimum time. Okay, so now therefore 1 plus 1 by n plus 1, 0 to 1 x to the power n minus 1 by 1 plus x square. Okay, so therefore in equal to pi by 4 into n plus 1 minus 1 by n plus 1. Here x to the power n minus 1 plus 1 means x to the power n by n, 0 to 1 plus 1 by n plus 1. Again I will do integration by parts and taking 1 by 1 plus x square as the first function. Okay. So here, no, I will take x to the power n minus 1 as the first function. Okay. So x to the power n minus 1 integration dx 1 by 1 plus x square. We know that integration dx 1 by 1 plus x square means tan inverse x. So we directly write this. If I take x to the power n minus 1 as the first function, so x to the power n minus 1 integration of 1 by 1 plus x square dx. So tan inverse x minus integration ddx of the first function. So what I have taken as first function, x to the power n minus 1. So n minus 1 x to the power n minus 1 minus 1 nx to the power n minus 1. So n minus 2 tan inverse x dx. Hope you have understood this step. Here also 0 to 1 third bracket closed, third parenthesis closed. Okay. So now what is the eraser? Okay. Okay. So therefore in equal to pi by 4 into n plus 1. Here if we put the limits minus 1 by n into n plus 1 plus 1 by n plus 1. Here also if we put the limit in this position, tan inverse 1 means pi by 4, and if we put 0, this term becomes 0, minus n minus 1 by n plus 1, 0 to 1 Okay, x to the power n minus 2 tan inverse x dx. I think up to this you have understood each and every single step. If you have any doubt, please reverse the video, watch the video again. You can understand all the steps, because it is very easy, nothing is there. Only calculation is little bit lengthy. So in equal to, here pi by 4 into n plus 1, two terms are there here, pi by 4 into n plus 1, so pi by 2 into n plus 1, pi by 2 into n plus 1. We just simply add these two identical terms, previous page, minus 1 by n into n plus 1, okay, minus n minus 1 by n plus 1. Now the magic begins. Here, watch this term. Watch this term. It is nothing but in. Check. I just remove the red marked area. Check whether it is in or not. In here, in where? See the question. In equal to 0 to 1 x to the power n. Sorry, it is in minus 2, because in is 0 to 1 x to the power n tan inverse x dx. Therefore, in minus 2 equal to 0 to 1 x to the power n minus 2 tan inverse x dx. Just we put n minus 2 in place of n. 0 to 1 x to the power n minus 2 tan inverse x dx. So see here, 0 to 1 x to the power n minus 2 tan inverse x dx. So this term is in minus 2. This is nothing but in minus 2. Hope you have understood this step. If you have any doubt, ask me in the comment section. So in equal to, therefore in equal to the minus n minus 1 in minus 2. In minus 2. Okay. So therefore, if we put n equal to n plus 2, where we are putting like this? Because here another condition is given, n into in plus 2 plus bn into in equal to cn. So what is the condition? We will write here, n into in plus 2, an into in plus 2, see previous page, plus bn in equal to cn, plus bn in equal to cn. So if we put n equal to n plus 2, then n plus 2 equal to pi by 2, n plus 2 plus 1, so n plus 3, minus 1 by n plus 2 n into n plus 3, minus n plus 2 minus 1 means n plus 1 and n plus 3, and here n equal to n plus 2 means n plus 2 minus 2, so in. So here we have in our hand this expression. So if we multiply throughout by n plus 3, because in the right hand side each term, denominator of each term has this n plus 3 terms, so we just multiply throughout by n plus 3 into n plus 2 equal to pi by 2 minus 1 by n plus 2 minus n plus 1 into in. So if we take this n plus 1 into in part from right hand side to left hand side, what we have in our hand is n plus 3 into in plus 2, n plus 3 into in plus 2 equal to pi by 2. plus n plus 1 into in plus n plus 1 into in equal to pi by 2 minus 1 by n plus 2. So now if we compare if we compare 1 with what? With n into in plus 2, an into in plus 2 plus bnin equal to cn. What we have in our hand is an in plus 2. So an equal to n plus 3 and bnin, so bn equal to n plus 1 and cn equal to pi by 2 minus 1 by n plus 2. Hope you have understood up to this step. So now also it has been mentioned in the question that the values of n are starting from 1 and so on. So n equal to 1, 2, 3. So if we put here for all n greater equal to 1, here a1 equal to 4, a2 equal to 5, a3 equal to 6 and so on. So therefore a1, a2, a3 a4 are in AP, arithmetic progression. Also b1 equal to 2, b2 equal to 3, b3 equal to 4 and so on. So therefore b1 b2 b3 are in AP. So now we will check the options. Here b1 b2 b3 are in AP and a1 a2 a3 are in AP. So we have reached to the end of this beautiful problem. We have here two correct options. So if we just simply tick this one and left D untick and check, then marks will be deducted. So be careful while writing the exams, or check if there are multiple options are correct, then only go to the next question. So hope you have enjoyed today's video. So please do subscribe to this channel, and I hope to see you in my next video.